We're going to look at the basic capabilities of the Reflex 950 test system. The Reflex 950 makes tests for high pot or dielectric withstanding voltage, leakage current or insulation resistance, and capacitance on devices with a high number of pins. The screen that you can see here is the typical operator screen, and it has three main features. This area here is a physical representation of the device that will be tested. In this case it's a connector with 155 pins. At the bottom here is a summary of a test sequence that will be performed on the device, and the test sequence comprises one or more test steps, in this case a high pot test, a leakage test, and another couple of high pot tests. There are some manual prompts in between which will enable me to demonstrate it in a moment. On the left hand side we have icons that control access to other test facilities, and if I click on the test data icon we can see the test sequence in more detail. If I open up the high pot test, we can see the typical high pot conditions that you would expect: the voltage that will be applied, 1500 volts, the dwell time of 0.3 of a second, and some other conditions that we can also edit. However, one of the most important conditions is to specify the pins that we would like to test. To work with these pins we use the pin editor. The pin editor has the task of allowing us to specify three types of pin assignments. At the bottom here we have a list of pins that for this test step will be connected high. So in the case of the high pot test, high means connected to the application test voltage, the high voltage. We have a list of pins which will be connected low, and in the case of the high pot test, low would mean the detection mechanism for measuring any high pot current that was flowing. And we've got also the possibility to specify pins that will be grounded, in other words pins that will take no part in the test. We also have what's called a scan method, and the scan method determines how the pins will be tested during this test step. So for example, the most simple test that we could make is to connect pin 1 to high, pin 2 to low, and select the scan method high to low. This is the simplest possible test we can make, and that will apply the test voltage to pin 1, it will detect on pin 2, and the result pass-fail of that test step will be the result of that test. Similarly, we can specify pins 10, 15 and 78 to be connected to our high group, and if we execute this pin configuration with the scan method high to low, these three high pins will be connected together and they will be tested relative to pin 2, which is low. The actual test routes are shown here in this area at the left. So you can see that there's one route generated for this test. Pins 10, 15 and 78 are all joined together and connected high. Pin 2 is connected low. Now we might wish to test pins 10, 15 and 78 individually to pin 2 instead of joining them as a group, because we might like to know which one fails the test. The price of this will be a longer test time, but more engineering information. And we can do that by changing the scan method to high stepped to low. This means that the test system will use an algorithm which walks through these individual routes. First of all pin 10 to 2, then 15 to 2 and 78 to 2, testing them individually one at a time. And in fact, if we click on each of these routes, we can then see a pictorial representation here of where the electrical test activity will take place.